Okay. All right, I think we're set up correctly. Okay. All right. Let's see here. So I haven't streamed for a while because at the beginning of the year, I had a whole bunch of stuff going on. My my wife and child got stranded because of the whole JFK shutdown because it was so cold. So they got stranded at the airport. And then after all that got worked out, I caught the flu. So I had to stop streaming for a while. But anyway, let's see. So today, what I wanted to try to do is hopefully I make this really quick. But if you didn't know, this is me on Instagram. And last year, 2017, I did. I was trying to learn Houdini, and so for 365 days, every day last year, I did one render a day in Houdini. Usually it was because I watched a tutorial every day, and then I tried to usually base my render off either the tutorial or just start going off on a tangent and trying to make something, and then I would post it. So I have about 365, or exactly 365 different renders, all done in Houdini. And so if you ever have any questions on any of this stuff that you see here, just hit me up, and then I could try to go over it and yeah, answer any questions that you might have. I mean, half the time I probably forgotten exactly what I did, but I mean, I have the project files, and I can always go take them apart, and I can even make them available to anybody who wants to take a look at it and kind of take them apart. So just hit me up through email or YouTube, or on Instagram at grantrants. All right. So today, and now let me just let you know, like, I still am very much a beginner in Houdini, and I really still have no idea what I'm doing. So by no means am I saying that I'm an expert at any of this stuff. So I'm probably doing a lot of things totally wrong, and just abusing the heck out of the program. And there's probably a lot of professionals out there that are probably yelling at me for the type of workflow that I do. So, just to give you that disclaimer. But today, what I wanted to do was, when I first started doing this whole 1 year of Houdini, the very first day, I actually had no idea what I was doing. I didn't even know how to render out of Houdini. And I have a Cinema 4D background. So what I did was it was January 1st, 2017. So because it was the first day of 2017, all I did was I used Houdini to to write out the word 2017, but I didn't even know how to get that out of Houdini. So I just did a screen cap, and then I brought that into Cinema 4D, and then I used Cinema 4D's Voronoi fracture object to create this. So I think this is the one. So on January 1st, 2017, and I posted that. So basically, I'm using Cinema 4D's Voronoi fracture object here, and using some Mograph effectors to switch it over from 6 to 7. And in Cinema 4D, it's actually actually a pretty easy process. But after I finished this entire year of all these renders, and it's like I said, I still have so much of Houdini that I have no idea what I'm doing, and there's so much more to learn still. But after a year of using it every day, I got a little comfortable with it, and I mean, things are still daunting and things are still hard to figure out. But I have the sense that I kind of sort of know what I'm doing now, and can sort of problem solve and create things that I want to create. And so the very last day, actually after the 365 days was over, I wanted to recreate what I did but do it fully in Houdini. So this is the one. So this is January 1st of this year. So exactly a year from that one with the 2017 using the Cinema 4D Voronoi fracture object. And I try to recreate the exact same thing. Sorry, that might have been really loud. So sorry about that because it had some audio in there. But I tried to recreate that. And so it actually took a while to actually recreate in Houdini to do the exact same thing. And you can see it's not the exact same thing, but something very similar. So it's possible. And so then you're going to ask, well, why don't you just do it in Cinema 4D because it's so much easier to do it in Cinema 4D. But being able to actually execute this and problem solve and get this done in Houdini was actually really helpful in learning some basic principles and fundamentals in Houdini. So I'm just going to go over that real quick, or hopefully real quick. We'll see. And I'll try to recreate what I did in Houdini. All right, so I'm going to open up the program. And you're going to hear me clicking around a lot because I actually have the original project open too, so I can sort of remember what I did and follow along. All right, and I'll do something more simple. I'll just break down a simple object. So I'm gonna tab and create a geometry in there. Dive into the geometry, and I'm gonna delete out this file because we're not gonna be referencing anything. So let's just go do something with a little more simple shapes today, and just do a box. Okay. And we'll just go from a box to something really, really, really simple, and just go to a sphere. All right. Sphere will be there. And let's get the sphere. So I've got this template object on, and so let's get the sphere to be a polygon, and let's give it a little bit more geometry there. And let's bring the uniform scale down just a little bit, so that's more in the same, about the same size as the cube. And then for the cube, we don't really need to, but let's just turn it from polygon to a polygon mesh so that it actually has some geometry to work with. And so we just set these two guys up because we're going to be kind of doing them in tandem and bringing them together. Okay, and so from there, what I think I did was I would have to use basically shadow them like a Voronoi fracture object. And so what I will do is I'm going to turn this thing into a volume. So I'm going to say B2B from polygons. I love my B2B from polygons. And I'm going to put that in there. But instead of the usual stuff where I turn it into an SDF volume and start to do some Boolean modeling with it, I'm going to turn it into density. I can fill the interior there. And let's see here. From there, I'm going to scatter some points. Let's scatter some points into that. And by default, it's going to scatter about 1,000 points in there. And that might be a bit much because each one of those points is going to turn into one of the pieces for the Voronoi fracture. So let's turn it down to like something like 100 for now. And I'll turn it up later because this is Houdini and everything's procedural. And so because it's Houdini and everything's procedural, we might want to do something like this and say like, let's put a null here. And just say like a side object. But and then for the sphere, what it's going to turn into, you can just make another null object and say this is the B side. Oops, the B side. All right, just to keep things a little more organized. So that you can always just put something else in here because, like I said, this is procedural, so we can just always switch out stuff after the fact, after we build out all this stuff. All right, so we've got about 100 points spread out on there, and let me just let's see, hit D and change my, where was it? Change my point size of my particles displaying so I can see a little bit better. Hopefully you guys can see them a little bit better. So now the particle's a little bit bigger for you guys to see, I hope. So let's make it a little bit bigger. Okay. All right, and so we've got that, and because we have, so what the Voronoi fracture, what the V2B from polygons did was actually not scatter points on the surface, but actually scatter it within our object. Because if you didn't have that on, let me just turn it off right here. If you didn't have it on, the scattered points would only go around on the surface, and that's not what we want. We actually want it to be in the volume there. And so with that, if you take a Voronoi fracture top in there, and you can below, right, there we go. And then we're going to input the geometry that we want to fracture, and then the points that we want to use as the fracture points, and we turn that on. This is what we get. It's going to take a little while to think about it, and there we go. So now we've got this Voronoi fracture object. And so just to visualize it, if you want to, you could just do this and put in exploded view. Exploded view, and put that in there. And you can see that, in fact, because we have put the points within a volume, you can actually see that all the pieces are actually within the volume. So if we didn't use this V2V from polygons and make it a volume to scatter those points in there, this is what would have happened. And you can't really tell right now, but each one of these, every point or every piece in here is touching the surface. And so it's actually a little bit more evident if I, for example, here, let me just pipe the sphere in here so I can show you what I'm talking about. So if you pipe the sphere in there, you see what happens? Every single point, because the point that's creating the fracture is on the surface, then every single point or every single piece that the Voronoi fracture fractures into is it has to go throughout the entire volume. And so that's not exactly what we want, because in this case, if we turn on our V2B from polygons again, you can check it out, and there. So we have actual pieces that are just on the inside and only exist on the inside, which is what we want. And this also shows you the procedural nature of Houdini, where you can just like pipe a different piece of geometry into a node, and you can get what you need to visualize something. So so here we are with our pieces, and of course with Houdini, if we want to, I'm gonna keep the detail on this pretty low, but you can always add into your detail. This is great. Cinema 4D just started doing this with R19, and it's funny because I keep seeing that Cinema 4D bring in functionality that Houdini has had, and they're doing a great job at it. It's awesome. And so the new Voronoi fracture object in R19 for Cinema 4D can do just this, and they can do all kinds of different things, just like how Houdini can do certain things, and it's pretty cool. So you can actually just add interior detail, and you could make the detail, give it a little bit more detail, and even the noise, because it kind of sort of warps the geometry in there, gives it a little bit of definition. You could actually change the amplitude of that, which is great too. And you get a lot of detail in here. I mean, if you push it a little bit too far and get way too much detail on here, I mean, your system will bog down. I can already hear the fans on my computer turning on from trying to calculate all this stuff. But and we're only doing it 100 pieces. We can get more pieces in here, and you can get more detail and stuff. But for today, we're gonna keep it a little simple and just make it a little bit less processor intensive. But like I said, you guys can do that. All right, so now we have our object that's fractured, and we don't need this exploded view anymore. The exploded view is cool because you get to kind of see it exploded. You can actually bring it back if you wanted to, but that's all it basically does. You can't really get too much other control off of this. So, so let's delete that. And then from here, what I want to do is I want to actually. So how we're going to do this is we're going to have the fracture go from the bottom to the top, just like how we had it in this example. Where this is actually going to be loud if I press play, so let's not press play on that. Let's go to the bottom one here, and what was it? 365 different renders previously. It should be right here. So here we go, and if you take a look at that, you can see that it moves through our object. So that's what we're going to try to recreate. And so if I go back here. How we're going to do that is we're going to attach everything by changing the color of this. So what we're going to do with this right now is Let's move this off a little bit to the side. So we'll get back to this, but basically we're going to just be doing the exact same thing on this side anyway. And so we're going to put a color stop. If my computer works, we're going to do there we go, color stop. Okay. This color stop. Let's connect this. Hello. Well, things are getting a little bit slow. Hello. There we go. Okay. So that color stop did nothing right now. Because it's set to white, and by default, our geometry is white. So let's just set it black so we can see what we're doing. So now we've turned it black, all right? But what I'd like to do is I'd like to gradually turn it white, and that's how we'll map our data onto our object. So what I'm gonna do is I'm gonna grab a plane, or a grid, sorry, a grid. This grid here, and let me just hit this to template it so I can see where this grid is. And we don't need it as big, but you can keep it actually relatively big because, say for example, you piped in a different object over here and it was a lot bigger than this original box. You know, you want to have your grid big enough to cover it, but right now the grid is like this big. So maybe we can bring that down a little bit by making this like a 5 by 5 or something. And even something smaller than that is fine. Maybe 3 by 3 is okay, I would think. And so what the grid is going to be using is actually the points. So if we go into point mode, you would see, well, actually, it's this. If we go into point mode, you'd see the points here. And so let's just increase that just by a little bit, just to make sure that we capture everything. So let's make it 25 by 25. Basically an arbitrary number, but so let's do that. Let's go back to here. So this grid, we don't need to see these points anymore, so I'm going to turn the points off. So this grid is also going to have its own color. So I'm just going to make a copy of this color node, put it here, but the color for this one is going to be white because we're going to map the data from black to white, basically from 0 to 1. Right? Black being 0 and white being 1. And so what we're going to do is we're going to use a attribute transfer. Attribute, I cannot spell today. Attribute transfer. We're going to transfer the attributes from this guy onto whatever goes into here. So if we do that, then it turned white because up until now it was black. We use the attribute transfer, it's turning white, right? But we need to have a little bit more control over that because it's turning the entire thing white. So, and the attribute that we've created is at the CD level, is at the point level. If you take a look at your geometry spreadsheet, you can actually see it in there. So the color, CD stands for color diffuse, but the color diffuse's R, G, and B values have been mapped to the points, not our vertices, not our vertices, and not our primitives. It's been on the points. So we're working at things on the point level here. So take a look. Go into here. We're going to be affecting points only, and you know, if you want to, you can even say it actually probably has this in here. By default, I think it's doing CD anyway, but you just tell it to transfer the CD, and then we're going to bring the distance threshold down. And so you see what it's doing. It is only transferring the attributes within this distance threshold, because here is where that plane is, right? So the plane is at that cut point, and it is transferring it onto it. The point, the reason why it's looking like this is because it's transferring onto the points of each of the Voronoi fracture object, the Voronoi pieces, and that has its own points in certain places, you know, so like right here and stuff. So that's why it's kind of giving this weird pattern right now. But if we just up the blending mode a little bit, you can see that it kind of gives you a little bit more to work with there, like that. And what we can do also is, let me just turn this down just a little bit so we get a little bit more of that action there. And if we up the grid a little bit, maybe, I think let's just go with like 50 and 50 just to make sure that we're more thorough with this. And what we're going to be doing is we're going to be moving that plane through this object, right? So we're going to use a transform. That did not work. Here we go, transform. We're going to grab this guy, and we're going to put it right here. And so through this node, we will transform the color, right? So now you see that the points from the plane are transferring their attributes onto the cube, or the Voronoi fracture cube. But we need this to be persistent, so it needs to stay over time. It needs to actually just build up and accumulate. So you want it to stay a white. And we could do this a different way, but the way I'm going to do it today is I'm going to use a solver SOP. The drawback with that is that it needs to actually, it's a dynamic, sort of like a dynamic system, so it needs to actually build up. While you do it, it needs to sort of simulate. So I'll explain what that does. But let's just get a solver SOP. So we grab this guy, and we're actually going to place this transfer attribute within the solver SOP because that's what we want to have it solve for. So we're going to grab this guy and we're going to cut him out, keep him in the clipboard. Here I'm going to paste him into there. So now he's looking for, so he is looking for, so we've got input 1 and input 2, which mimics what input 1 and input 2 are here. And this grabs the previous frame. And so on frame 0, or frame 1, there's no previous frame. So just to help us without getting errors, we're going to use a switch node. I'm going to put this on here and grab this and put this into port 1 and this in port 2. This is important to do it this way so that this guy is on this side and this guy is inputted on this side. And I'm going to bring that into here. So basically, just like how the input 1 went through, but this switch is making it look at input 0 for now. And we're just going to make it look at input 0 just for the first frame. So when it's on frame 1, it just needs to be looking at 0. So we're going to say $f equals 1. And so what that does is when it is on, is that correct? Yes, when it is on frame 1, it should be, right, when it's on frame 1, it is looking at input 1, which is just directly transferring over. But as soon as you go to the next frame, now it will go to the input 0, which is the previous frame. So it'll start pulling in the previous frame now instead of pulling in input 1. So that's exactly what we wanted it to do. So let's reset this and go back to frame 1. And then what we want to do from there is then bring in the plane from here and start affecting it by doing the exact same thing that we did before. But now, because we're doing it in a solver SOP, it's going to do it over time. So if I pull out from here and I actually press play, what happens with and sorry, I'm going to have to, totally didn't do this correctly. I have to keyframe this. So I'm going to see where our plane is at. And our plane is right here. And so when I bring this, oops, that did not. The Y plane. We're going to start from here. And let me just put a keyframe there. So I'm going to put a keyframe there. And let's just say at frame 71, let's grab this guy and pull this guy all the way up. And he will go through the entire thing. All right. So I'm going to hold Option and put the keyframe there. So we've got 2 keyframes in here. And so now if I go through it, press play, the color will persist because it's being solved on every frame and it's bringing in the previous frame and building upon it. So it persists. So now we go from white, from black to white. So we've mapped it from black to white. And that's that part. Okay, so from there, what we're going to do is we need to bring this into a for each loop. Bring this into a for each loop, and since it turned into version 16.5, we have all these crazy different types of for eaches. So let me see. I want to for each connected piece, for each name primitive. I think it is. Sorry, folks, I'm not familiar with this. I think it's this. Yeah. Right? So let's find out. So grab this guy onto here, and the way to figure out if this is correct is I can just look at single passes. Yeah, and if a single pass, I can just take a look, and you can see that it's passing through every single piece. So what a for each loop does is it will execute, because it gives you this whole crazy block of stuff. Whatever you put in between these 2 orange guys, it will execute that for each piece that you assign to what a piece is, or a, what were the other options for each, connected piece, or a named primitive, or for each number or point or primitive. You can actually execute for every single one of those. And so what we're going to be doing is we're going to be executing what's inside here for each piece of our Voronoi fracture object, which is pretty cool. And so the way I test that out is I go to the bottom node here, and I can just say, show me just one single pass of it, and I can see what each pass looks like, and I can go through all of them. So I know that each one is one piece and it's doing everything correctly. So I'm going to turn that back off so I can see the entire thing here. And within here, for all of these guys, what I'm going to be doing is, first, what I want to do is I want to pack them. So I'm going to put a packed object, or pack SOP. Basically, what a pack SOP does is it turns, if I pack, let's see, pack full geometry, I think that's correct. Yes, I believe so. But I do want to transfer the attributes of CD onto each point. What a pack object does is it turns each of those points, or it turns each of those pieces basically and represents them by one point. It's a little more complex than that, and a little more nuanced than that. But for all intents and purposes, for what we're doing today, just know that basically we turned each of these pieces sort of into one point. It's kind of like how, if you're familiar with C4D's Mograph, if you put something in a fracture object, or like in a Mo text, each one of those letters is represented by one point. So if you're going to do like a Mograph selection, it's represented by one point. It's kind of like doing sort of the same thing, where it's representing each piece, but now by one point instead of by a ton of points. So if you take a look, now I've selected points to show where points are. There are no points to show, right? Because each one is represented by its internal point. Like if I go into, I've never tried this before, but if I go into X-ray mode, wireframe, yeah, then you can see that the points are now within each piece. Like if I went back here and I did the same thing and I did a single pass, so now you can see that there's one point here represented for this piece. I hope that makes sense. Because if I didn't have this pack object, so let me turn it off, you can see that the points, there are a ton of points, because that's exactly where the points actually are. But because you use the packed object, basically what it does is it represents that piece by just one point now. And that's kind of what we want. So do that. And then on top of that, we're going to put, let's see here. I don't remember if this is super necessary, but actually it probably isn't. Yeah, I don't think it is. Okay, so what we're going to do is put a point VOP. So put a, whoops, point VOP. I'm pretty sure that this could be executed all with Vex, but I have no confidence in my Vex writing skills. So let's get this back to smooth wire shaded. Yeah, that's better. Okay, so we're going to go into this point VOP. And what we're going to do here is, I'm going to do a ton of stuff. First of all, we are going to, everything, and the way this thing is going to break up is going to be using some noise to actually give it some randomness. So for now, what we're going to do is, first thing we're going to do is put an anti-alias noise on there. So we're going to get some anti-alias noise down there. And let's see if I did anything to this. So there's going to be a 3D input, because we're going to be taking the position from here. So it's going to be a 3D input, putting the position here. And it's going to give it, we need it to give us a 3D output as well. So now we have that going on there. And I think we'll change this up later, but yeah, we'll change it up later. Basically, we're going to pump this into there. And then from there, what I want to do is convert that into a float. Right, so I'm going to take that vector that's coming out of there and put it in the vector to float. Float. Right. I'm going to take the 3 vectors coming out there and turn them into each one of their values. Okay. And now, the thing I want to do is I want to kind of affect it so that the noise pushes out each of these or changes the position of each of these pieces in their x and constrain it to an xy, and not so much affect an xz, the xz plane, and not so much affects the y, because our plane is going through. So I don't want to push the pieces too far up or down. I mean, they can go a little bit, but not so much. So that's why we separated out our x, y, and z right here. And I'm going to put them back together by doing a float to vector. Float the vector here. So we're just going to port over the x and the z, but with the y, I'm going to multiply it by a constant. Okay, that's how we do that. And so I'm going to put that guy right here and port the noisy y and multiply it by a constant. And that constant is going to be, right now, it's not doing anything because multiplying it at 1, but let me just make it like 1.15 maybe for now. We'll just do that. And so now we have our noise, but the noise on the y coordinate is kind of being dampened by this multiply by constant. All right. And so after we did that, we are going to also multiply it by the color. Okay, so we're going to multiply this noise, I'm going to multiply it by our color. And if you remember, our color is either basically, it's black or white and gradations between there. So we're going to grab the CD attribute and we'll put that into our color. Okay, after we do that, all we've got to do now is we are going to add an add node. We're going to add this hello with our original position of our points. Okay. Oops, sorry, that is not supposed to be there. It's supposed to be here. So let's, whoops. Come on. Here. Go into the position here. Okay, we're gonna add that into the position there. Then let's grab this guy. And I believe this is not correct. Right. But, well, actually, if it's here, is that correct? So, see how it's not affecting anything that's black, but it is affecting everything that's white. In my example, I actually added it again for some reason, but let me see what that is actually doing. So if I grab another add, again, I think I wanted to double it up. Maybe that's what I was trying to do. I don't recall exactly what this is going to do. So if I put this into here and put it there, yeah, it actually kind of doubles it up, I guess. It gives it a little bit more of a different look. I don't even know if that's correct, folks. I'm going to just not do that. Just keep it, oops, that shouldn't be. Just keep it like this. All right, and I'm curious to see if switching up the order, so making this the original position and adding it to this changes up anything. No, that doesn't really change up anything. Okay, so that's what we're doing with that. And so that's what's taking care of our position, right? So now we can just use this anti-alias noise here, and we can actually just tweak it a little bit to something more of our liking. So let's just make the frequency a little bit higher. Maybe make it like 10 by 10 by 10, I guess, something to that effect. And make the amplitude maybe not make it so high, or maybe make it a lot higher. Let's actually right click on this and go to VOPs options and create input parameters so that all of these get put on here. And what that does is it gives us the ability to control this on the outside. So we get all of our inputs here now, so we can control it through here. All right, and that's not the only thing we need to do here. The next thing we need to do is we need to so we've used this point VOP to control the position, but we also want the noise to control the rotation. So we want to give the rotation a little bit of noise, and the scaling a little bit of. We want the color to affect the rotation and also the scaling. So we need to make some attributes to help control that. So what I'm going to do is actually I'm going to give us a little bit more screen space because I want to see more of what's going on here. All right. So that's all going to be controlled through the color. So what I'm going to do with the color is I'm going to let's work on scale first. And so I want to scale it down to 0. So right now, white is 1 and black is 0. So I'm going to need sort of the opposite of that. So let's grab our color, but let's subtract. Let's do a subtract. Like I said, since white is 1 and black is 0, I actually kind of want it to be the opposite of that because I want to scale it to 0. And so when it's white, when it's 1, I want it to be 0. And when it's black, I want it to be a normal scale, which is 1, but black is 0, right? I hope this is making sense, guys. And so what I need to do is I need to invert them. So I'm going to use a constant. Oops, I can't spell constant. All right. So we're going to do a constant, and this constant is going to be a value of 1. Okay. This actually needs to be a vector, I believe, since we're having a bit minus from a vector. So 1, 1, 1. All right. And so we're going to pipe that into here. And from there, we're going to subtract our CD, our color. So now we just inverted it. And so if I do that, and I do so if I take that, and I only need is one attribute from there. So I'm going to just do a vector float just to be safe. Vector float. And so we only need one of these values. Since we're working with black and white, they're all the same anyway. And when I'm going to put a ramp in between here, so I have a little bit of control over how it looks. And this is going to be a spline ramp. All right. And then from there, I'm going to do a bind export. I'm going to bind export it to. So what bind export does is whatever value that we have in here up until this point, it's going to export it out as any attribute that we want. So we're going to call this attribute. I don't want to make an attribute name that might be used again for something else by default in Houdini. So I'm just going to give it a unique name. So I want it to control scale. So I'm just going to say G scale, so that I know it's my scale attribute. All right. So we're going to use G scale. And then the next thing I want to do is I want to also have control. I want to have the noise and the color also control the rotation. And so the way we're going to do that is we're going to grab the color again, but this time I want to multiply. If I did this right, I want to multiply the position vector and multiply it by a constant. Constant is going to be something really high. So in my example project file. I had something set to like 720. So we'll adjust that later to see what's going on. But and what that's going to do is it's going to multiply it, and then from there I want to multiply it again so that I have it separated out. I want to multiply this again by, I think, by our CD. And from there, I'm going to bind export again. And we're going to call this rotation. So I'm going to call it, oops, you can't see what I'm saying, writing that, grot. All right. So we're exporting out a scale, something I'm going to use for scale, and something that I'm going to use for the rotation. And so if I go back out here now and I select this node, I can see my geometry spreadsheet that we created. We have our color here, and we have a rotation attribute that's, because it's times by 720, I guess this is why we're getting these crazy numbers. And then the G scale is set to 0. They're all set to 0, actually. They're all set to 0 because of that ramp, because of this ramp. And even though it looks like it's ramping this way here, if you set this thing to spline ramp, and it looks like it's scale mapping it from 0 to 1 like it should be. If I go out here, you can see that's not. It defaults to 0 for some reason. So I'm just going to grab this guy and make the value 1. I do that. Go back to here. You can see that my G scale now all has actual, values, and so they have some type of value here. These values. No, it's not. So it's between 0 and 1. Okay. So so now if I take a look at that too, it's not doing anything because right now those are just attributes that I've tacked onto there and not really used them for anything yet. So next, what I'm going to do is I'm going to use those attributes, and so I'm going to grab those attributes by grabbing a primitive top. And what that primitive SOP is going to do is I'm going to turn on do transform because I do want to transform it. And I think by default, it sets the pivot point to the center point, which is basically where the Voronoi fracture point is, which is basically where the packed point becomes. So it does that by default. And so what I want to do now is I want to scale. I want to use the scale rotation that the scale attribute that we created to scale it. So I'm going to say at G scale, what it was, I believe. So I'm going to copy this, paste, and paste. So take a look. Everything that we did kind of scaled down to 0, which I think right now, because we don't really have too much of a ramp, so our values aren't being mapped very well. The reason being is because of this solver SOP, I think. We're not really getting, we are getting a ramp here, but because we're getting a, oh, wait a minute, that's where, because we need to, let's see, transfer, if we're transferring the attributes, do we need to, I think we need to, the reason why we're not getting it all correctly is because we need to get the average, I believe. Well, it wasn't a problem before, so let's keep going and see. This might need a little bit of a workaround. So if we go into the solver SOP and give it a little bit more of a blend width, so something more like that, I would believe. The problem with that is because it's in a solver SOP and now has to we have to redo these dynamics. And so, oh yeah, see, so now that we've done that, it actually scales them down a little bit. But we kind of need to, you see how this turned orange? We kind of need to redo those. So we're going to do this, and we can actually see it working. See, so it's actually working. There we go. Look at that. Isn't that cool? Okay. I kind of want to map it differently, and we can go do that. But first, let's fix the rest of this stuff too. So the rotation also is going to be we did a grot, I believe, but we're going to do it by x I'm going to do a at grot y, and then at grot.z. Oops, is that even correct? Yeah. Yes. So now they all rotate. So they should rotate anyways while they're getting scaled down. But the scaling is too aggressive, and that's why we kind of put that ramp in there. So we're going to go to this ramp, and we're going to actually try to ramp this a little bit better. So it scales really quickly. So let's see if it's on this side. Does it? Yeah, there we go. I want it to scale not as aggressively. So let's grab all these guys, make it something more like cat not wrong? No, Bezier. Yeah, that's cool. And so, oops, I don't need to do that. So we can do this and bring this guy in so that it sort of gradually kind of scales down. And so, there you go. And I think we can affect our positions a little bit more drastically because they're not really moving around that much. So first of all, let me just turn off this points. We don't need to see the points. What we can do is go into our point VOP and go into the noise. We have the noise controls out here. So we can say the amplitude, we can actually turn that into something bigger. So it pushes things out further, I guess. Move things around. Okay. And so after we've done that part, then we can actually, I'm going to stick a merge here, and I'll show you why later, but let's do a merge right here. Show the exact same thing. And then I want to unpack our geometry. Up until now, it's all been packed. So I want to actually kind of unpack it right here. So now it's back to being actual points. So if I go to points, you can actually see they're actual points, right? And that's crazy that they actually keeps the other points there too. But so all the points are back, because if we don't have that on, then they're not points anymore. We do that. But also we want to get rid of this color on here, because we want to color it whatever we want to, their own stuff. And I don't want to kind of have that color. So I'm going to clean some attributes off of there. And so if I clean the attributes off of there, let's remove attributes. There we go. So I'm just removing all attributes. So I think that's good. And then from there, what I can do is I kind of have to build out the B side of this. But we've done basically all of the work, which is pretty cool. So what I want to do now is do almost the exact same thing on the sphere side. And the cool thing about that is, because we've done all this, I can just basically check this out. So up until this merge, because that's why we put that merge there, I'm going to grab all of these guys and hold Option and duplicate them onto this side. Okay. And what I need to do now is just make sure that this guy goes into here, this guy goes into here. Everything else should be the same, and merge. Oops, don't do that. So because everything is selected, just need to grab this one guy here and merge that into there. All right. And so with that, we get this, and you get to see our sphere. But what's happening is our sphere and our box are doing the same thing. They're doing the exact same transform. And that's not what we want. And so in order to do the opposite, all they need to do is reverse their colors. And so what we can do actually is actually just reverse the colors. So we could probably just get away with, dare I try to use a, I mean, actually, turn this into, instead make this white. Right, and so we're transferring white onto white. But instead of that, we're going to make this branch off and be black instead. And so that goes into there, and this is going to be black. So that should be the opposite now, and everything should be working in an opposite fashion, I believe. It's not looking right because I think we need to re-simulate this, I hope. But that's all we need to do, I believe. The cool thing also what I want to do is I want to copy this parameter and paste it into here if we ever want to up the, so paste relative reference if we want to up the amount of fractures that we have. Because we're probably going to do that. I'm probably going to do that. But let's reset our timeline back to 0. And this is not working correctly because I think what we did was we upped the blend. Because we upped the blend distance on our solver SOP, what I want to do now is actually, you know what? We're not doing this efficiently because kind of, no, we do need to have 2 solvers. Yeah. And so this needs to start off lower. So let's grab his handle and make him start off with just a little bit lower. And I think maybe he needs to go up higher too, but let's see. So what happens is it's going to push through. Yeah, there we go, there we go. Sort of get it to turn into a sphere. And that's totally fine, it totally makes it. Again, what I don't like is I want more of a delay between here. It looks like the sphere turns on before the, yeah, see, it looks like the sphere turns on or starts appearing before the box starts breaking up. And that's probably because we're using the same distances, we're using the same parameters here, but the box is actually physically smaller. So the pieces are, the color transfer, the transfer of the attributes is affecting the sphere pieces first before it starts affecting the box. And so what we can do with that is actually, well, if we do it, just a simple thing, we could change up things. We could change up the solver. We could go in here and we could change up the, go into here and we could change up the attributes and see how far it affects what the distance threshold is and things like that. But I mean, another way to do that is all we'd have to do is just put a time shift. Just time shift it by a little bit, just by a few frames. So this is $F. Let me just say $F plus 2 or something. I think, or sorry, it should be $F minus 2. Minus 2. Yeah. So I would think that would do that. So now, is that making it better or worse? No, it actually looks like it's worse. So maybe like -5, -6. Maybe that's too far. -4. Yeah, -5 is. All right, let's just keep it at 6. All right. So now we can mix this there, and yeah, they kind of break more in unison, right? I like that better. There we go. And I mean, that's basically it. You can do a render to see what it looks like, but for the most part, that's it. That's how we would affect it. We could actually do different things where instead of using a plane to affect it, we could just scatter more points around here, and then the distance from that point. So like if we had multiple points along the geometry, it could start like affecting, spreading out and kind of changing as it goes. But, you know, I mean, that would be a different aesthetic too. And you can do different things like that. If we changed, one other thing we could do, if we changed the way that the points are scattered, or just the points, how points are in general, we could change it from being a Voronoi fracture to something more, or to something less organic pieces and more like symmetric geometry. So we could put a volume from points, or sorry, points from volume. points from volume. So you got to grab a, where did that get attached to? You got attached to the very end. Where did I put that just now? There's, oh, I don't need to, oh, good God, I don't need to do that. So let me turn that off. Delete that. There are points from volume. Oh, you get what I mean. I would love to show you that, but I'm gonna have to get going already, or my hour is up. But if we had points that kind of separate this out into a more geometric pattern, it would actually break it up into something more symmetric. But as is right now, this works. Yep. So you know, I hope you learned something, and I hope you like what you see. And yeah, I'll see you next time. Like I said, I'm totally have no idea what I'm doing, so it's not like you should take this as the guide of how to do something. But thanks for watching.